To determine the non-permissible values, assess each trig function individually and examine any expressions, or we're going to specifically look at fractions that may have non-permissible values. So we're going to look at example 1 to determine the NPVs. So determine the non-permissible values in radians and degrees. So we're going to look at each of these three trig functions individually. And we want to think about whether we can write them as a fraction. So secant theta is 1 over cos theta, which means that it's going to have a non-permissible value because it has a fraction. You can't have 0 in the denominator. So this means that cos theta cannot equal 0. So we're going to look at the unit circle to figure out where that would occur. So essentially you're solving for cos theta equals 0. So remember that cos theta is the x value. So when you look at your circle, that would be here at pi by 2 and here at 3 pi by 2. And every time we rotate it around. So we'll take the smallest angle and say pi by 2 plus a distance of pi n. So theta cannot equal pi over 2 plus pi n, where n is the element of integers. If we were to write this in degrees instead of saying pi by 2, we'll say 90 degrees plus 180 degrees n, where n is still the element of integers. Let's look at tan theta individually. Tan theta can be written as a fraction. It is equal to sine theta over cos theta. So once again, cos theta is in the denominator. Cos theta cannot equal to 0, so we would have the same NPVs here. Sine theta. Sine theta on its own has no NPVs individually. If you think of the curve for sine theta, when you graph it, we have no asymptotes. It's a nice, smooth sine wave curve. So there are no asymptotes in there, or no NPVs. However, we need to look at the fact that we have a fraction here in the question. And so if we look at, so we'll say, however, tan theta over sine theta, now you have sine theta in the denominator. So sine theta cannot equal 0. So that is going to occur on the circle at 0, pi, 2 pi, 3 pi, 4 pi, etc. So we would say theta cannot equal pi n, where n is the element of integers, or if we were writing it in degrees, this question asks for both, we would say 180 degrees, and with the same variable, n is the element of integers. So we want to combine this whole question together. So our NPVs, it's helpful to look at the circle, occur pi by 2, 3 pi by 2, and also this. So it's actually every 90 degrees or every distance of pi by 2. So when we combine these, we would say theta cannot equal pi over 2 n, where n is the element of integers, or if it was in degrees, theta cannot equal 90 degrees n, where n is the element of integers.